So these are some of the artificial reefs that we're going to be installing in a harbor in Denmark in April time. And so when we're putting them in the harbor, it's important that they don't interfere with any of the boats coming in to use it. And so that's why they're placed in these crevices on the steel wall. And
Gotcha.
so we have the reefs here on the seabed, and these ones were inspired by the natural boulder reefs that used to be found in the Baltic Sea. But most of these have been removed for use in construction. And so you're left with these kind of sandy bottoms where very little can grow and survive because there isn't anywhere to hide. So these provide a nice little area for things to grow and hide in. And I can show you some footage after this of some fish that we have and other species that like to hang around in here.
So what species would colonize the bottom part? Is it just fish or anything else as well?
Mainly fish, crabs, and starfish.
That's a great start.
Yes, we got some really nice data from the other ones, including some cod coming to visit as well, which was very nice. And then these ones up here are mounted on the harbor wall. And so in our other pilot project, we saw these were colonized very quickly. Within a month, we got 100% coverage of barnacles, algae, and some other species. And yeah, so these ones are very nice for your kind of sessile organisms. We get more coverage up here because it's closer to the surface.
Yeah. And the material is completely biomass.
That one is clay that we'll be installing. We're still developing the biomaterial, but it's about 70% shells, the biomaterial.
Binding carbon.
Yeah.
So why are we using clay for 3D printing, and why would you use biomass for 3D printing?
So we use the clay. We use a low carbonate clay because it's got much lower CO2 emissions. And then in Denmark, we're using an electric kiln. A lot of the electricity comes from renewable resources. And the clay also has a neutral surface pH, so it means that marine life can attach to it straight away.
How will then endemic species find their way into these structures? What about clay and biomass? Would endemics latch on them, or again, invasive species win?
It should be a much fairer kind of challenge. If you do have invasive species, they could also come there first, but they kind of are more like a level playing field to begin with.
That's awesome.
It's pretty nice.
And that will help the endemics.
It should do, yeah. We've made it mainly with shells because there's lots of papers showing that marine life likes to colonize on natural materials and ones that have a similar kind of pH to shells and things. So some species or kind of organisms are more fussy than others. So oysters are pretty fussy and they like to settle on other shells. So we tried to make the material as similar as possible to what we find in nature, and then we also make sure it has like a rougher surface texture as well, because that makes it a lot easier for marine life to settle on as well.
I think, Shannon, you're doing amazing work with Reef Circular. I really wish you a lot of success with this. And like I say, I've identified your project as very interesting with high potential of doing marine restoration, and I just want to support you.